I can edit out this conversation. This never happened. Or maybe it did, I don't know. So formulas. So the first formula is the most important one. So it's the integral of 1 over, you should memorize this one for sure. If you have 1 over x dx and you're integrating it, it's ln, absolute value of x, plus c. So very important formula, very important formula. I'm going to drop my notes. So you can write this a different way. You could write it like this. You could bring the x upstairs and write it like this. It's the same thing, okay? You can also write it like this, dx over x. So all of these are the same. If you try to use the power rule, remember the power rule, it says you add 1 and divide. You would get, like if you try to do it wrong, you would add 1, you'd get x to the 0 over 0, and it doesn't work, right? So like if you have x squared, you just do x to the 3 over 3 plus c. But if you have x to the negative 1, instead you just use this formula here, okay? So if you have x to the negative 1 or 1 over x, it's always natural log, and don't forget the absolute value. Okay, that's the main formula in this section, okay? There's a couple more formulas though, okay? They're not so bad. These next two, I don't really have them memorized, but I can do them in my head, and that's why I can do them, right? So let's talk about it. So that's probably a better way. If you have the integral of tangent with respect to x, so tangent with respect to x. So tangent is what over what? What function over what function? Sine over cosine. Yeah, sine over cosine. So let's just think about it. So if it's sine over cosine, if you had to do that, right, you would let u be the bottom piece. So you would let u be cosine, right? You would let u be cosine. I'll just do it. Why not? I wasn't going to do it, but this is like the first example. So first time you're seeing this. And then you would compute du. What's the derivative of cosine? Is it sine or is it negative sine?
It's negative.
Negative. It's got that annoying negative sign. I wish we could just ignore it, but we can't because that would be wrong. So it's negative sine x dx. And then what you can do is you have to make this look like whatever is here. That's called your integrand. So you have to multiply by negative 1. Right? So you get negative du equals sine x dx. Right? And then so what happens is this whole thing here, I wish it was taller, I wish it was like 8 feet tall. This becomes, so sine x dx becomes negative du, right, the top piece. And what do we usually do with the negative signs? What do we pull them? Pull it out. Yeah, you can just pull it out. It's usually better. So negative du over u, right, over u. And then you know what du over u is like dx over x. It's the same thing, right? So this becomes negative ln absolute value of u plus c. Eventually you can do this in your head, or at least you can think about it in your head. And then this becomes negative ln absolute value of cosine x plus c. So that's not the formula in the book. The book, they say ln secant. What they do is they put the negative up top, and they write it as cosine to the negative 1, which is 1 over cosine, which is secant. So crazy stuff. I memorized it like this because I say, oh, it's sine over cosine. Okay, so u is cosine. Derivative of cosine is negative. Oh yeah, this could be negative ln cosine x plus c. Again, it's sine over cosine. U is going to be your cosine. It goes on the bottom. So you're going to get an ln with the cosine. But the derivative of cosine is negative, so you're going to get a negative. So that thought process lets you figure it out without having to memorize it. Because if you just try to like memorize it without understanding it, you'll forget it, right, in your other classes. Which I mean, it's okay, I guess, but it just depends what your other classes will be. 3, we can do cotangent with the same mentality, right? Cotangent using the same thinking. So cotangent is cosine over sine, right? So our u is going to be sine, but the derivative of sine is cosine, yeah. So there's not going to be a negative. This will just be ln absolute value sine x plus c. There's no negative this time because the derivative of, oops, that's going to sound bad. The derivative of, I had to burp and I did that and like, the derivative of, okay, not in the video, the derivative of sine is cosine, so there's no negative. So there's no negative. Mm-hmm. So these, should you memorize these? It's up to you. You can always work them out, right? Whatever you want to do, right? So So if this is on test, you can show the work or not show the work. It's totally up to you on these, right? 4. I think 4 is, I think we've got to the cool one. Yeah, this one's ridiculous. The integral of secant. This one's crazy. So the integral of secant, okay, this is actually equal to the natural log of the absolute value of secant x plus tangent x plus c. I say, what? Yeah, I'll show you how to do it in a minute. This is where you learn it. Like, this is the class. This is the moment where you're supposed to learn how to do this. It's in the book. Most people forget this formula. Like, most people in my differential equations class, they forget the formula. Like, on the final last semester, the first question, they had to know the formula. Yeah, it's just normal. It's part of life. But I'll show you how to do it, right, so that you don't forget it maybe. If you know how to do it, you'll never forget it. That's how I know it, because I know how to do it. So we'll come back to it. 5. Otherwise, I'd forget that. How in the world would I remember that crazy formula, right? It's because I know how to do it. 5. So then I'll show you how. Then once you know how, you'll never forget it, like you'll know for the rest of your life. So when you're 100 years old, and someone asks you what the integral of secant is, you'll know when if you make it to 100. What is it called if you live to be 100? What is that called? What are they called? Centenaries?
Starts with a C.
Yeah. So, I don't know. Okay. So cosecant's the same. Cosecant's the same. So this is negative ln cosecant x plus cotangent x. Maybe by the time we're 100, people will live to 200, and then we'll live to 200. Or maybe not. So you all are the science majors. Is it possible to live to 200? No, right? No.
I believe I was like 119.
119 is pretty good. Okay, so let's do the integral of secant. Let's do this one really quickly. What? No, okay, let's do it. Come on, check it out. Integral of secant. I know they look really scary. It's not that scary though. Integral of secant is really weird. So here's the trick for the integral of secant. This is going to make no sense. It's like it comes out of nowhere. The trick is to multiply by this, which is just 1. You might say, why in the world would you do this? Right, we're basically multiplying by 1. You say, why? You'll see. I didn't come up with this. No. This is something like, it's on Wikipedia, it's in the book, right? This is something someone else did, not something I did. Okay. So this is just 1. So you say, why would you do this? When you do this, something amazing is going to happen, right? Which I'll show you. So we're multiplying by secant, so you can distribute the secant. So you get secant times secant, so you get secant squared. Okay. Then you get secant times tangent, so you get secant tangent. Over, and then on the bottom, you just have secant plus tangent, right? This is really weird. You'll see what happens now. I remember the first time I saw this, I was like, wow. Like, it was like, whoa, what a clever trick, okay? So we basically multiplied by 1 and we got this. And now you'll see why we did it. If you call the bottom piece u, something really weird happens. Look, if you let u equal secant plus tangent, and you compute du, let's see, so du. Anyone remember, what is the derivative of secant tangent? Yep. Secant tangent. And what is the derivative of tangent? Secant squared. Very good. And then parentheses dx. So it works out perfectly. It's rigged. So by doing this trick, all of this, right, shows up right here. Look, it's all of this. Isn't that cool? The whole top piece is right there. You see it? It's pretty amazing, right? No, I think it's amazing. I mean, look at that. Look, so this is going to become, so the top piece is what? du, right? And what's the bottom piece? u. Yeah, that's it, right? Isn't that cool? It's just like magic, right? Is there another way to do it? Yes, but I don't know how, right? I was reading about it on Wikipedia. I'm like, no, it's too complicated. I don't care. I didn't have time or something. But this is the easiest way to do it. So clever trick. And this is ln, absolute value of u plus c. So this is going to be ln secant I was thinking about the other one. I was thinking about cosecant plus tangent plus c, and that's it. So kind of a cool problem, right? So once you see it done once, you'll never forget it. So if you remember the trick, so if you remember that you have to do this to do it, you'll memorize the answer, right? Because the answer is this, you see? If you say, oh, that's that really weird problem where we have to multiply by secant plus tangent over secant plus tangent. That's how you do it. You say, oh, then that means that's the answer. So if you memorize how to do it, then you actually know the answer. So kind of interesting. Kind of an interesting problem. Cool. Anyone think that's cool? No one thinks it's cool? Anyone? A little bit? Najib? Yeah? Good. Extra credit? No. All right, let's do some homework. There's no more notes in this section. Let's do number one is kind of easy, but let's do it. So number one from the homework. Good, like final exam warm-up question. 8 over x minus 7 dx. Really easy problem. I think every single problem in this section is an integral, I think. Yep, every single one. It's perfect. So we have to make a substitution. Any ideas on what our u could be? X minus 7, good. Good idea. So u is equal to x minus 7. That's a good first. Great. This was on the final last year, I think. One like this. Because it's easy, you can do it in like 5 minutes. You have to leave, Belle?
No.
Oh, okay. So du is just dx, right? It's dx. Du is dx. Because the derivative of x is 1, the derivative of 7 is 0. So then it just becomes 8 over u du. That's it. Right? Because that's your u, and that's your du. Right? Yeah. No, we let u be x minus 7. So the derivative of x is 1. So it's 1 dx. The derivative of u is du. The derivative of x is 1 dx. The h is hang. Oh, I didn't multiply by the 8. Oh, you're thinking, oh, right, because usually we make it match. I didn't do that. So yes. So she's saying, when we got here, don't you have to multiply by 8? No, I decided to be really lazy and just let the 8 hang out. Like just let it hang out. And so the 8 just stays there. And then the dx becomes your du. You could do it like that too. You don't have to make it match. You can. Yeah, sure. You can do 8 du equals 8 dx. Yeah, you could do that. And then you say, okay, 8 dx, that's the same thing as 8 du, right? Right? Same thing. And then on the bottom, you just get u. Right? Because 8 dx is 8 du, so it's the same thing. It's the same thing. Same thing. You can pull it outside. You want to pull? We can. We can. It doesn't matter. It's up to you. I mean, you can. You can if you want to.
Can we just say strictly to what we do?
No, because there's many ways to do it. No, it's good. It's good for you. It's good. Who leaves it? Who lets it? Who lets the 8 hang out? I'm just curious. Anyone let the 8 hang out? A couple people. Okay, huh?
Whatever you taught us.
Huh? Well, okay. So this is equal to 8. The 8 hangs out. What's 1 over u going to become? What's that integrate to? We just did it. We just started this section, so maybe you don't know. Is it on the board still? ln. Good. Whoever said that. Good. 8 ln. Absolute value of u. Oh, this is our first example. Plus c. We're almost done. Yeah, it's this formula here. Right, the first one. So then this is going to be 8, and then you just replace u with what it is. So it'd be ln absolute value. What was u? X minus 7 plus c. Yes, that's it. So a couple different ways to do it, right? You can let the 8 hang out. You can not let it hang out. We should definitely do number 2. Because it's the same. Hey, how about you try number 2? That's perfect. Because number 2 is a little bit harder, so it's perfect. Here we go, number 2. Integral. And anyone know what it is? Anyone have it? Number 2?
1 over 17 minus 7/19.
All right, yeah, try it. See if you can do it. See if you can do it. It's a great test. They're all really good, all of these problems. All right, let me do it. So you let u equal the bottom piece, right? 17 minus 7x, right? Okay. And then you take du, right? So du is negative 7 dx. This is really good. Not only does it help you for the fourth test, it helps you for the final, plus it helps you for more math, right? This is a really good question. Then, now let's do like what we've been doing. Lydia's gone, so it's kind of sad. So, but negative 7 dx, that's not there. So we need to get rid of the negative 7, right? So what do we do with the negative 7? We do what? Divide, yeah. So we divide by negative 7, divide by negative 7. Okay, so it goes away. So we get that. And then usually we can write it as negative 1 over 7 du, right? So we can do this. We can write it like this. Negative 1 over 7 du equals dx, right? It's a better way to write it, right? So now we're ready to make our substitution, right? So the negative 1 over 7, I know over there, like I didn't pull stuff out. I did it differently. I was just doing whatever. That's good, though. It's good to see like different ways of doing it. That's probably how I would do it if I was just whatever. Hey, all right. All right, so then you get negative 1/7. And then du. Right, that's replacing the dx, and then we just have 1 over u. Yeah, good, 1 over u. Who got this far? Just curious. Okay. Did you almost get there, Chris? You didn't raise your hand. Did you almost get this far?
Yeah.
Good. Okay, I was like, did Chris get it? Because the bottom piece is u.
Where did the, so you don't write the du over?
You can.
Oh, okay.
You can. You got it right?
Oh, yeah, I did.
Oh, so this is negative 1/7 ln absolute value of u, and then plus c. It's tough. This is tough. Once you get through this, like you'll be okay. Like you can do it every.
So, like I got the same answer, but I didn't separate the 1 over.
What do you left it as du over u?
Yeah.
That's fine. That's fine. That's fine. So this is negative 1/7 ln absolute value, and then just replace your u with what it is. U is 17 minus 7x. This is 17 minus 7x plus c, and that's it. That's it. Who got it right? Just curious.
What if
Good.
we don't plug in u? How many points?
Minus 1.
Okay.
Yeah, I feel bad if that happens. Like, I actually feel bad for you, because like there's actually pity there. like, because I know you know how to do it, right? So that's just like a, yeah. It's sad. All right, student number. See, no. Yes, we have to do number 3. We should do it. Number 3 is a really good question as well. So 3. So we have ln x to the, is it 7, I think?
Yes.
7 over a great test question. Again, all of these are really good. I only left, most of the homework is really, really good. There used to be like 20-something questions, and so I just left like the best questions in the homework. That's why there's only like 11, right? So make sure you do all of them. They're totally worth doing. This one's really interesting because it's different than the other ones. This will like destroy Calc 2 students sometimes. Any ideas on what u could be? ln x. Yeah, it's a good try, right? So let u equal ln x, and then just take du. So du would be 1 over x dx. 1 over x dx. And if you don't know, just try something. Like even if you don't see the full solution, you let u be ln x, and then you hope for the best, right? And then maybe you'll get it right. And then if you don't get it right, it's okay. It's better than not trying, right? So it's better to try and fail, because maybe you won't fail. Maybe you'll get it right. So then 1 over x dx is right there, right? That's the 1 over x dx. It's the same thing as this. That's just that's your du, right? This is the same thing as this. So this is going to become u to the 7th du, right? Because that's your u. So it becomes u to the 7th du. Do you see it?
Why didn't you put the du on the bottom?
Oh,
You're doing the thing again.
you see it? Oh, good, Genesis. Oh, it's good that you see it. No, it's good. It's good. It's really good. It's almost over, you know. Today's like the 12th, I think.
Today's the 11th.
11th? Okay, so December 11th, there is no school, right? The semester's over. Your grade's been posted. You're thinking about Christmas probably, I think, or whatever you do. I mean, it just, yeah.
What are you doing for Christmas?
Huh?
What are you doing?
I have a tree and like presents and stuff, and you know, see my family. And I've actually never been to a graduation, not even my own, ever. It's really bad. I've never been to any of my graduations. I don't know. I just never been to any of them. It's really sad. I know. So I've never been to any graduation of my own. I graduated like 1,000,000 times. I never got any. U to the 8 over 8. You add 1 and divide. Let's see. I watched it on the internet once. I had a student. He's like, "You got to watch me. I'm a graduate." So I went on my laptop and I watched it for like 20 minutes. But
You should try to make it.
yeah, maybe I should go. I don't know. Maybe. So ln x is u. So this is, be really careful when you write the answer here, okay? Are you graduating this year, Mary?
Yeah.
Oh, it's good. Where are you going after this, UCF?
I don't know yet.
That's good. So be careful. Notice the parentheses around the ln x, right? See where the parentheses is? It's important to have the parentheses. If you don't have it, it's technically incorrect because it means something else, right? So because if you write this, that's not the same thing. Like, where's the 8? Is it on the x or is it on the ln? You know what I mean? So it's really important. That's a common place for like a -1 on the test. It's really like, so don't make that mistake. It's better if you just get them all right. Let's keep going. Yeah, it's really easy to grade the test if you get 100. So, I mean, so much better. What is going on there? Maybe we should do, you want to try 4? Or should I do it? 4's not bad. 4 and 5. Let's do 5. I'll leave 4 to you. 4 is kind of...
No, I wasn't saying like leave it to us.
Okay, fine, let's do 4. 4. Let's do 4. 4. It is a little bit annoying, so let's do it. So we have the integral of dx over... I think 4 is more annoying than 5. X, parentheses, ln x to the 8th, and then it's like this. And then it's like this, and there's a 9 here. It's really scary looking. It's really kind of weird. So let's do this one. This one's kind of annoying because there's a step we can do, I think, to make it easier on us, right? It looks really horrible, doesn't it? I know, that's why I didn't want to do it, but let's do it. So you see this 8 here? You can put it in the front here, right? That might make it better. So let's do that. Let's write it like this. dx, x, okay? And take this 8 and just put it in front of the ln like this. It'll be 8 ln x to the what? 9.
Oh.
Yeah, it makes it easier, right?
So is that going to be our u?
Yeah, it's going to be our u. Good, Ayana. It's going to be our u. It makes it much easier. So u would be 8 ln x. 8 ln x. Yeah, so du, you want to try to finish it? See if you can do it? Yeah, try to do it. See if you can do it. See if you, why not? We got time. What kind of, yeah. It's good. No, it's good. Are you taking Calc 2?
No.
Oh,
I'm a bio major. I don't want to.
sad. No, it's good. It's good. It's good.
Yeah.
Janice, are you taking Calc 2? No.
No.
No, that's right. Sad. A lot of you are really good at not taking Calc 2. You're not taking Calc 2 either? Yeah, I know. It's really sad. Huh? You say you're not good at math? Oh, that's so sad. That's not true.
So, wait.
What? Wait, we forgot dx.
Wait, what are the posters due?
Today, I think. I think if they email it to Aaron, right? It's today.
Yeah.
It has to be like completed by like midnight, I think. Is there a time? Yeah,
By midnight?
probably. I mean, if you send it to him by midnight and he says no, be like, oh, please, it doesn't say on the website, you know. So, did you finish it, yours? You did? You submitted it?
No, I didn't submit it.
Yeah, okay. Did you ever get in touch with Jorge? I saw him at the library, and I talked to him about you. So, yeah, that's it. That's the story. He said he would contact you and stuff, so it's good. It's good. Yeah, are you doing it? Are you all doing it today? It's good. Yeah, well. So dark. All right, let's finish this. So du is 8. I know it's a lot of pressure. I know. ln x, that's why you have that choice between tutoring, is I feel like it's a lot. The derivative of ln is 1 over x. Very good, Maria, 1 over x. So it's 1 over x dx. Ah, I see, said the blind man. But there is no 8 here, right? So you have to get rid of the 8 by dividing by the 8. So it'll be 1/8 du equals, I'm going to write it like this, dx over x, just to be different. Why is it falling apart? Dx over x. Like that. Okay. So now the dx over x is 1/8 du, right? So this piece here is 1/8 du. So this is going to become equals 1/8 integral. And so dx over x is 1/8 du. So you can pull out the 1/8, right? So we get du over u to the 9th, right, to the 9th. Once you're doing these and you can do all of these, you know how to integrate. You are good at it, right? These are considered like harder, I think, in Calc 1. I mean, this is pretty tough stuff. And then this comes up a lot in Calc 2. Like, it's a big deal. Everyone see how we did that? So the dx over x is the 1/8 in the du. We pulled out the 1/8, right? That's what happened to this, right? Dx over x is 1/8 du. And then we're left with the u to the 9 on the bottom. I know it's tough. Let me just pause here. It's tough. This is supposed to be hard. Whenever it's one formula. 1 over x gives you that ln x, but like it opens up the door for like more difficulty. And just looking at it and seeing the pattern, it takes a lot of practice and effort and time. It's not something that's like immediate. If it is, like there's something going on up there, it's great. It's good. That's good for you. We have to integrate this. Any ideas on what we can do with this? Where can we bring it to integrate it? To the top. Yes, very good. So this becomes 1/8 integral. When we bring it up, what happens to the 9? It becomes negative. Very good. So,
Yeah, you did.
yep. So now we add 1, right, and integrate. So we drop the integral sign, we drop the du. So it'll be 1/8 u to the -8 over -8 plus c, because we're adding 1. -9 plus 1 is -8, and we divide by that number. So you add 1 and divide by the number. Then you just multiply these. So you get 8 times -8 is -64. Bring the u downstairs so it becomes a positive, and then just go ahead and plug back in your u. So your u was 8 ln x. So it'll be 8 ln x to the 8th, ridiculous, plus c. Someone should type this in and see if it's correct. It looks crazy, right? The answer looks insane, right? So basically, we brought this back down, and the -8 became a positive 8, and then we replaced u with what it was. U was 8 ln x, right? That's over here, right? U was 8 ln x. Crazy problem, right? I'm glad I did it. I'm glad we did it instead of skipping it. It looked really bad. What made it worse was this 8, right? It makes it look really scary. Like, what the heck, that 8. If you don't do this, then when you call this u, you have to use a chain rule, like, and it's really messy, right? It still works, but like, it's just harder. Any questions on any of the stats, please ask. We have time, I think, so. Anyone like this stuff besides me? Anyone? A little bit? No? Najib, you don't like it? No, Najib. Paul, you like this stuff? Like, no? A little bit? No. Emily, a little bit? Chris? No questions? No. All right. I'll leave 5 to you. Let's do 6. Let's do 6. 6. 6 is, I believe 6 is it theta?
Yes,
Tan
theta to the square d.
d theta. This is kind of annoying. We should do it. It's not hard. This is actually not that hard. So in order to do this one, we'll make an assumption. We'll make the assumption that we know this formula. That's probably the best way to do it. So we know the formula for tangent, let's say. So we know the tangent of x. Well, let's see. So tangent is sine over cosine. So u is cosine. The derivative of cosine is negative sine. Cosine's in the bottom, so it's ln cosine, because cosine is in the bottom, so it's ln cosine. The derivative of cosine is negative, so it's ln and a negative. So this is the formula we're going to use for this problem, right? So we'll make that assumption. It makes it easier. If you don't use the formula, you have to write it as sine over cosine, and then there's a chain rule. It's a little bit messier, so it's a lot messier. Okay, so now that we know this, right, all we have to do is make a u sub here. So what do you think our u substitution should be in this case? What do you think we should use for u? 8 theta squared, yeah. So just the inside piece here, okay? So 8 theta squared. So u is 8 theta squared. Okay. Just to compute du. So du would be 16 theta d theta. Then divide by 16. So good. Divide by 16, divide by 16. Divide by 16, divide by 16. No, the tangent will hang out.
Oh, because it's, okay.
Mm-hmm. So it'll be 1/16 du equals, I wonder how many examples we've done today. It's like, it seems like we've done like tons of problems, like, I don't know, gazillion. It's not really a number. So 1/16 du is theta d theta. So, oh, I see it. Look, theta d theta is 1/16 du. So that works out beautifully, right? I mean, this is beautiful. Integration is really like, it's great when you know how to do it. So this is equal to, pull out the 1/16, right? Pull out the 1/16 and we have a du, I believe. I hope I did that right. Yeah, 1/16 du, yep. And then it's tangent of u, right? Tangent of u, tangent of u.
Do we have to clear? Or we don't?
No, that was the u piece. And now we take the integral using the formula. So it'll be negative ln cosine of u plus c.
So the 16 still hangs out?
It still hangs out. I like how you said it. Hangs out, yep. It's like that friend that just never goes away. No, I'm kidding. So negative ln cosine of u and then plus c. Plus c. So then this is equal to negative 1/16 ln cosine, and then u was 8 theta squared. So this is 8 theta squared plus c, and that would be the final answer for that one. So not so bad. Actually, that's not true. That was pretty tough. So any questions on that one? So let's try, let's do number 8. Let's do number 8. But any questions on these so far? So 8's actually easier. It's a good test question, 8. It's a little bit easier though than this one. Hey, all right. So number 8. Number 8. 8 is a little bit annoying in the way it's written. It's the integral of secant of x over 8. So it's this. It's integral secant x over 8 dx. So the way it's written is not really so convenient. You want to think about it before you integrate it. You want to think about it as secant of 1/8 x, right? At least you want to think about it that way because you're going to have to make a substitution, right? So we know the formula for the integral of secant, right? It's ln absolute value secant plus tangent. So all you have to do is get rid of the 1/8 x, right? So you make a u substitution at the beginning of the problem. So you start by letting u be equal to 1/8 x. Right, you want to get the secant by itself, right? And then you just use the formula. So then when you take the derivative, it'll just be du equals 1/8 dx. See, because if you write it as x over 8, it's harder to think about the derivative, right? You want to think about it like this so that you can take the derivative. What do we do next with the, what do you think we do next? Multiply by 8, yes. Because there is no 8 out here, right? So multiply by 8, so you put an 8 here, put an 8 here. So we get 8, that's an ugly 8. 8 du equals dx, equals dx. And that's it. That's it. So now we make the substitution. So this is equal to So the dx is 8 du, so you pull out the 8. So you get 8 integral secant u du. Right? 8 integral secant u du. This one's actually really easy in the sense that it's all about, do you know the formula? If you know the formula, you'll be able to get it right. And then now we just have to integrate. So then it's 8 ln, absolute value, and it's secant u plus tangent u, and then plus c. Right? It's ln secant plus tangent. Ln secant plus tangent. Most people don't like this formula, but once you like, if you actually go through it and like figure it out, you'll never forget it, right? Because it's such a weird technique, such a weird method to come up with this formula. Are we done? No. What do we have to do? Plug in u. Yeah. So if you forget to do that, it's yeah. So it's ln secant x over 8. I'm going to write it as x over 8, just to save room, plus tangent x over 8 plus c. And that would be the final answer. That's it. Any questions on this one? That was number 8. 7 is the same. It's cosecant. 9 is easy. 10 is the same as the other one. 11 is not so bad. I mean, we could do 11 if you want. Let's do it. Let's do 11. 11 is really easy. 11. One more. Last one. 11. I think we've done more examples today than like, I don't know, it seems like we've done a lot, right? Like just tons, there hasn't been many notes. It's just problems. So how about this one? Cosine t, and then here we have 8 plus sine t, dt. Do you all want to try this one on your own, maybe? No? Yes? Yes, try it. Someone said yes, try it. See if you could do it.
Yeah, you look really professional.
Right here.
Oh, it's there.
So you let u equal 8 plus sine t. So I bought it for that, and I figured I could use it for class too, so I got this. So I figured I could just do both.
Okay, I want
So that's what you do for u. And then your du is just cosine t, dt. And that's it. Right, that's it. Now we can make the substitution. This is a great, I love this problem. Like, there was no like multiplying by 4, no dividing. It's just clean, you know, it just works out. They should all be like this. So cosine t dt, we need longer arms. Cosine t dt is du. So you just get du over, what goes on the bottom? U. Yes, u. So you get ln absolute value of u plus c. So then you just get ln absolute value 8 plus sine t plus c. And that is the final answer. Who got it right? Just curious. Good stuff. I think you got this.